Hey, welcome back to part 6 of the dream home build. There's going to be a lot to unpack in this video, but just a quick recap. So we've been building for roughly 18 weeks. The framing is more or less done, the windows are in, the roof is on the house. But before moving on to the next big things like the radiant heating in the house, the electrical, the plumbing and all that, I needed to button up a few things. This included picking up the garage doors and installing a temporary yard hydrant because I actually did not have any water up until this point. We had a water meter installed, but no running water. So I wanted some kind of temporary water solution. There was also some framing in the master shower that was bothering me, so I wanted to address that as well. And I also needed to prep a few areas on the house for siding. And finally, we were gonna have our concrete patio poured and the concrete slab in the garage poured, so I needed to make sure those places were prepped and ready to go. So stick around. I am here to pick up my garage doors. Got two doors. There is a 18 foot wide door and a 10 foot wide door, and both doors are 8 feet tall. So a good friend of ours hooked us up with some good deals at AMAR Garage Doors. So here we are. So I'm by no means an expert in plumbing, but I want to go ahead and try it like this anyway. Seen it done online, and if this was a permanent solution, which it's not permanent, this is temporary water, I'd probably use some more heavy-duty fittings and all that, but because this is temporary, I want to try it out. Worst case scenario, I will have to go and get some different fittings that are more durable. So go ahead and thread that on. Just got to be careful not to get too much into the PEX. This is a PEX, by the way, and the actual line coming out of the water meter is HDPE, and you can't use PEX expansion joints or fittings on this stuff. So now to keep the actual yard hydrant up, I got this T-post in here, and I'm going to just sort of temporarily tie it just like that. There's going to be some gravel on the bottom of this, and most important thing is that we're 32 inches below ground. And actually, before I fill anything up, I want to take a tape measure and confirm we're 32 inches because that is our frost line here, so it needs to be below that. Yard hydrants are self-draining, so whenever you close it, the water level goes down and drains out of there's actually a little valve on there. And so you want something that'll let the water seep through. Obviously this is clay and sand, and we don't want to get it gunked up and clog that drainage, because otherwise water will build up in the actual pipe and freeze. Another thing, I did just measure this depth here, and you would think it's a no-brainer because the water line I'm dealing with was put in by the county, and they probably know what they're doing. But I did check, and it was right around 32 inches, not deeper. So that's kind of what I'm working with here. And I can adjust it, give or take a few inches, but really that water line is where it is. So I'm gonna add some gravel in here and rock for drainage and get going. Now if you're smart, not like me, you probably go get some gravel, some clean 3/4 inch gravel. But I got a gravel driveway here, and I'm not about to go buy more gravel. I'm just gonna use that gravel from my driveway. And here's what we got. We got the hydrant, the PEX piece. We have an adapter, of course, the male NPT that goes into the female, and there's a 90-degree elbow for 1 inch to 1 inch. I got my clamp here ready to go. This is actually leaning on my T-post right now. It's fairly straight. This isn't rocket science. You know, we're not trying to impress anybody. We just need water. So I'm gonna go ahead and tighten everything up. For the meantime, I'll use duct tape to hold this on so it doesn't go anywhere. And then I'm gonna actuate the water meter, basically open up the pressure. And if it springs a massive leak, then we'll know that this is not good. So let's find out. Kind of scared right now. because why? Because I don't trust my own work. But you know what? Whatever. Let me grab some pliers, channel locks here, and I'm gonna open up the meter. Literally for the first time too. I have never used water here before. I've been paying a flat fixed meter fee. This is the guy right here that you turn right there. You can actually lock it too, so that nobody comes to your property and opens up the water meter and, you know, gets free water. Interesting. I wonder if the water company meant to do that. I wonder if that's just a release valve. Huh. I'll have to check on that. It could be freeze damage if the water keeps coming out of there. Let's go over here. I got nothing. I got no leaks. What do you know? Hey, we have water, and check it out. It's peeing. That's what it does. It pees. So the extra water in the actual column is draining, and it's still draining. Anyway, I need to cover. That's good to know, because I need to cover this whole area in gravel, because if I put dirt on there, it's going to turn into muck and it'll clog that little opening. That way that water that drains doesn't clog itself. It doesn't turn into a self-clogging mechanism. Here's my little wire. Get some of that on there just to keep it. Of course the dirt's gonna hold this thing up pretty well, but that helps. In the interest of not having to call the company, I just went ahead and tightened that nut over there. It was just very loose, so I had to tighten it up and there's no more leaking. It's funny because if I wouldn't have done that, they would just come out here and do the same thing. But it would have taken them who knows how long. By the way, in the future, when we would run the main water line to the house, I would move the yard hydrant to another spot in the backyard. I just think it's very handy, obviously, to have a yard hydrant in such a large yard in addition to the water spigots on the house itself, especially, like I said, with such a large yard. And when we did move the hydrant, I found out that nothing was leaking, but I was actually scolded by the excavation guy for the method that I used to connect the water hydrant to the main line. Mostly he wasn't very happy about the fittings that I was using, but oh well, they worked for the time being. Corners in the back of my walk outside, and these are basically where that foundation turns in for more stability instead of just ending on a foundation wall. They turned it in a couple feet. These are not on the plan, but that's something that the foundation guy suggested we do. However, the problem with that is you have siding that goes on here and then it abruptly stops, and you have this concrete little corner. Now, there's a lot of things you can do there, but one option is to put siding on it as well. And the way you would do that is you need, first of all, to waterproof this material here to create a water barrier, moisture barrier. And then you want to put the zip sheathing on it. And then, you'll seal it up with the flashing tape and continue on your siding. Of course, when we get to here, it's important to remember that the siding is going to require a much shorter nail, because typical 2.5-inch nails are going to go through the sheeting and hit the concrete pretty quickly, which wouldn't be good. So I've got some stuff here. It's at the local hardware store. I don't know how good it is, but I think it'll do the job. We're just going to put a coat of that on. As you can see, we already have waterproofing on, but they just do it, you know, in certain areas. So I'm adding it on myself. This is like 60 bucks for this. It's not too horrible. You brush it or roll it on. It's black. So, but first thing I want to do is I want to wash this and let it dry. There's a lot of mud on here from rain and stuff, so it's got to be clean. Once the waterproofing dried, I covered the necessary areas with zip sheathing using tap cons and covered and rolled all the seams with zip tape. Now let me explain what you're seeing here. A concrete patio will be poured over the subflooring here. It's basically a suspended concrete slab under which is a storm shelter. But the problem is if it rains and it's really windy or perhaps snow gets piled up on the concrete, water will try to make its way between the concrete and the zip sheathing and ultimately leaking into the shelter room. I've had this happen in our old house. I've had relatives complain about this as well, and so on. So, two things are done to prevent water. On top, there is a flashing that is kicked out, as you can see, to force water away from the sheathing. All of this flashing, everything, will be embedded in the concrete. Secondly, there is zip flashing tape for anything that makes it past that first line of defense, and again, kicks it out from the sheathing. And so far to this day, I've not seen a single drop of water leaking through. And here is my good friend taking an attempt using the zip tape roller. I told him that, hey, if I can't see indented Z's in tape, then he's not doing it right.
What about now?
Same thing. Oh, no. Oh, okay, let's do it. I'll check.
No.
Can I see it?
Yeah.
Yeah, I think I see some Z's. Very nice. Okay.
And out of curiosity, I asked my concrete guy if he's ever seen anybody else use metal flashing like the way we did. And if I recall correctly, he said it was something he'd never seen before, but realized it made a lot of good sense. And by the way, this idea was floated to me by my uncle, who's a GC, and had also experienced issues with storm shelters leaking and whatnot.
Final load of heat sheet. Hopefully the final load. In fact, if anything, we might bring one back here to return because we'll have too much. So we've got a situation here where this little area here is a walk-in shower. In other words, I walk in and I'm in the shower and I walk out. However, the unique thing is that this wall, this little dividing wall, does not go all the way up to the ceiling. It's 90 inches tall. And because of that, just because of the way it sits, it doesn't terminate anywhere. It's very wobbly. So I had a couple of suggestions as to what to do to make it more stable. At the very minimum, we need a threshold for this type of shower anyway. This is not a curbless shower, so I guess it needs a curb, which equates to 2 studs. But that doesn't really solve the issue all the way. Kind of does a little bit, but there's still a lot of wobble. I mean, even though there's a stud, a base plate there's still plenty of wobble. So the suggestion that I got was to run a lawn stud. I just took one out. A lawn stud that penetrates through the subfloor and gets anchored between 2 floor joists. The floor joists run this way, right? And we did verify that we're between floor joists in this location. And so the way we're going to anchor it is the following way. I'm going to cut out the slot for the stud, and I'm making it as tight as possible. It may even be too tight for the first try, because I don't want it to be too loose to where it wobbles too much. Now I just got to get a perpendicular board, screw it in everywhere. So here's kind of what the end result looks like. We've got that stud going down, and then I have a engineered board going across. The engineered board is secured between the two joists using long screws, and so is the stud. You can use nails probably, but I figured I'd use screws in case I need to move something. And then of course we're gonna chop that stud down so it's not just sticking out there like that. And if plumbing or anything needs to go through there, they should be able to probably just bore through, but I don't think anything goes through here except for the radiant, which I already thought about that. And we're gonna just make sure those two lines are on both sides of that stud. And I have enough of a cavity there on top of that cross member. Really a huge improvement. The wall is a lot more stable. I mean, it moves a little bit, but once we put the sheeting on it for tile, like, you know, even concrete backer board, that'll actually kind of tie it together, keep it from swaying as much. So yeah, I guess that's one way to do it.
Well, that still didn't work. So you see, the issue is I wanted to put tile on the entire wall, on both sides, everywhere. And if you've got a wall that is wobbly or moving around, you know, you're gonna have grout that's gonna crack, and worst case scenario, you're probably even gonna get broken tile. And that just wasn't gonna work, too much risk. So ultimately, after talking to an expert tile installer, he recommended that I run the framing from the edge, sort of top corner of that freestanding wall up into the ceiling. And that's what I ultimately did. I undid my work and did that instead, as you can see here. Kind of wish I would have done that in the beginning, but lesson learned. What he's doing here is checking the consistency of the concrete and telling the driver to add more water to the mix. He ended up doing this about 2 or 3 times before being completely happy with the result. I thought it was kind of cool because just by eyeballing the concrete coming out, he was able to tell whether it was too thick or not. And I guess that's just what many years of experience does to you. Also, you can see that the entire garage slab has radiant heating installed, and that's those red lines looping back and forth. We did this exactly the same way as we did the installation for radiant heating in the basement slab. And if you want to see a detailed video of that, check out part 2 of the home build.
Be like the other.